Welcome to the Artificial Intelligence Podcast, ranked in the top 2% of over 7 million podcasts on Spotify. I'm your host, Dr. Tony Huang, and today we're with a special guest, Carter. Can you introduce yourself?
Hi, I'm Carter Huffman, CTO and one of the co-founders at Modulate. Super nice to be on the podcast.
So Carter, voice recognition has been declared like a solved problem at least 3 times in the last 20 years, which I think is kind of funny. And yet, like the voice AI stack still breaks constantly in prod. So, like an analysis of like 4 million real production calls found that traditional analytics tools miss like 60% of voice specific failures. So, like, kind of what's going on with like live audio when they try to put it into prod in industry?
It's a really challenging problem. We have a ton of our own neural hardware in our brains devoted to understanding audio, and it's not just around what sounds are you making, but there's a ton of context-based language decoding of what kind of thing are you saying? What do I expect you to say? And then are you matching those expectations or are you violating them? So actually understanding what somebody's saying is a really, really difficult and intelligence demanding kind of task. And so when you see things break in production, oftentimes it can be due to things like noise or background problems or bad audio. And as models have evolved and gotten better at solving those problems, people are pretty fast to declare, okay, great, now we've solved transcription. But then you think about the context of what am I saying in this conversation? What are we even talking about? Like, if we're talking about a location, I'm talking about the name of a town. How is the transcription algorithm going to know about that, right? That's kind of another level of understanding needed to process that accurately. Those are a lot of the kinds of failures we're seeing nowadays, and it requires a different level of intelligence than transcription did years ago.
Now, the industry has this thing called a transcript trap where dev teams like test these voice agents against transcripts. It scores really high in terms of accuracy, like maybe like 95% accuracy. And then they ship it into prod and it falls apart on like real calls because of like latency, automatic speech recognition errors, like interruption handling sometimes for like that are invisible in text. So, like, how widespread is this problem? And then why does it take like teams so long to kind of like realize that they're testing like the wrong thing?
Trying to build any kind of voice-based system is really, really difficult to test because audio is such a subjective and multifaceted kind of data set, right? Like it's very easy to scroll your eyes down a long list of text and see a long list of text responses and very quickly in parallel validate a bunch of data yourself. And that human validation step is extremely important in something as difficult as is your human experience of interacting with this system successful or not? Audio, you have to listen to that carefully one at a time, right? And think about when you're calling into a call center, for example, and talking to a voice bot. Are you frustrated? Are you like getting what you need? Are you just angry because this person sounds like a robot and you're having a bad day? These all require not just listening to that audio data, but you as a subjective user kind of placing yourself into that conversation and saying, like, what is my perception and experience of this voice system that's interacting back at me? So, kind of analyzing and validating that data and then putting yourself in a place where you can understand that conversation and see that back and forth and say, is this working or is that not? All is very difficult and also very hard to scale, very hard to parallelize.
Yeah, I had a buddy who worked at AT&T and they were building up like a voice bot, or at least like a ambient voice scribe that would like listen in on calls, and it would listen to like the pitch and tone of your voice, and it would give the customer service reps like prompts to de-escalate the situation. Is that kind of what you're seeing like companies doing to overcome just a text only type of approach?
I think that Ultimately, those kinds of systems can be useful and can be effective, but once you're talking to a human being, a lot of the time, are they understanding your emotional nuance is not actually the problem, right? Like human beings are very good at understanding what is the person feeling on the other side. I think the two big problems that people run into are one, just you're talking to a human and they're not empowered to solve your problem, which is a process problem and a tooling problem. But then the other big problem that people are encountering more and more as this technology is getting deployed more widely is that the voice bots that are responding in place of a human don't have those kinds of priors that we're so used to a human being having. So just like you mentioned this system where you're like, hey, is this person frustrated? Is this person angry? When you're building out a script for a human to engage with another human and a human agent to answer that call, they are already built. You have decades of experience responding to people that are angry or frustrated, right? You do it every day as a human being. These voice bots have no experience doing that, they have no context. And so you're trying to build a system that previously would be occupied by a human with all that context, and now they don't. And so you have these very, very challenging and frustrating experiences interacting with these bots.
I also found that like language models alone account for like 70% of like the total voice agent latency. Humans like they start to feel disconnected because of like the silence because that's like hardwired across like our culture. But so many I find that many like production systems today are hitting like 6 to 8 seconds like end to end, and like complex agentic workflows also reach like say 15 to like 30 seconds. So like at what point does like an enterprise realize that they've built something that's technically impressive but operationally unusable?
Well, ultimately, what you need to be thinking about is how are people used to having voice conversations? We're not used to talking to technology, right? Like Siri and Alexa are how old? And everybody knows what it's like to talk to Siri and Alexa, right? You have a different set of expectations. You're giving the technology a command and it's obeying or not. We're not used to having a voice conversation with technology, but we are used to having a voice conversation with other human beings. And how do other human beings work, right? They don't just, as you mentioned, sit there and wait for 10 seconds while they think before they respond. We view that as like something weird's going on that's super unnatural. They're talking and responding to what you're saying while they're thinking and while they're processing. There's a lot going on in parallel, and a lot of it's hierarchical. So I can be thinking about your problem and trying to understand your problem while I'm to you and asking you more questions and gathering more information. And the problem statement is that voice bots and voice agents are still very, very early in their infancy. So they're solving one problem at a time. Can I solve the problem at all? They're not optimizing for that voice UX where you need to be asking questions and engaging in parallel while you're solving the problem.
And I also find that like the dominant instinct right now in AI in general is like when you're in doubt, you just use a bigger language model. But voice is where like that breaks the hardest, in my opinion. So, like for instance, like reasoning models are way too slow for live response loops, and like a 5% drop in like automatic speech recognition accuracy doesn't just mean 5% of the words are wrong. It corrupts like the language model's input, which generates a wrong response, and then the text to speech delivers it with like full confidence, which I feel is kind of interesting. So like that entire chain kind of like degrades. So like why does like having a bigger model doesn't actually solve like the problem with live audio?
Well, it's partially correct, which is the problem, right? Like that if that were just completely wrong, then I think people would catch on relatively quickly, but it's partially correct because as you mentioned, the transcription models will very confidently produce their outputs, or even if they're producing like multiple possible hypotheses, that's a very difficult type of output to work with. And you as a human being, you don't have 100% accuracy, 0% word error rate, right? Like you misunderstand what somebody else is saying all the time, and then you fill it in and you figure it out as the conversation goes on, as that person is talking, with the extra context. And the trap here, the difficult piece, is that large models and reasoning models are actually very good at that. if you pose that task and you use them correctly, but they're slow. And so if you are able to use those where they're appropriate, like let me have a running understanding of the conversation. And as I'm gathering more data, I'm building that better understanding. And that's helping me respond to this person more effectively, then that's fantastic. But in the meantime, if you're not engaging with that person in real time with the low latency that they expect, it's super awkward. And then they know they're talking to a bot and they're thrown off and they're already frustrated and it just becomes a bad experience. And so that's the tricky part is that those bigger models are part of the answer, but they're not the whole answer.
Now, I find that like teams succeeding in like live voice environments are often building orchestrated like systems using smaller specialized models for like handling emotion, like maybe timing, stress, escalation separately, and then fusing those signals together rather than routing everything through one big language model. What did building for like adversarial, noisy, real-time environments actually teach you that directly applies to like enterprise contact centers?
It's exactly that ensemble and fusion approach that you just described. So when we were building models to understand audio in a variety of different environments, like we started in gaming and then moved on to call centers, very different environments and can also have very different subsets, right? I can be calling in from a phone in a noisy bus, or I can be calling in over a VoIP line, two very, very different kinds of environments. The biggest lesson we got is that you can build extremely fast, extremely accurate, and extremely high performing models if they are specialized to individual environments where they can perform very, very well. But if you're trying to make one model in isolation that does everything and performs perfectly in every environment, it's going to be way too big and way too slow, and you're going to end up with that poor experience for that voice communication in a real-time scenario. And so by instead specializing, building a ton of tiny, efficient, but still accurate models, and then selecting the right models that you need to apply to each domain, you can achieve the latency that you need while also still maintaining the accuracy.
I've always thought like language models were like sociopaths where they can predict the next word, but they can't predict like the emotional state of the user. So like an example of that would be like if you're at a hospital, you can have a bot that sounds like really cheerful when a patient's reporting like chronic pain. That's a liability. Or for instance, a financial bot that sounds bored when like a client reports fraud is a churn risk, right? So what signals does a transcription only system just completely miss, and like what are the consequences when it does?
It's exactly that empathy for the user and responding appropriately to achieve the outcome that your system wants to achieve that gets missed if you're just reading a transcript. And it's not just that emotional state at any given time, but also how that changes and evolves over the course of the conversation compared to a baseline, right? You start talking to somebody and they come on and they're saying, "Hey, I'm having a rough time. I need help. Like, can you help me figure this out?" And you say, "Absolutely, sure thing. Let me help." And they're sounding more calm. Maybe they just got from the IVR system to you, a real human, and they're like super excited about that and relieved. You can run with that and maintain that. But if they start sounding even a little bit more frustrated, you pick up on that and you can de escalate right away. If you're only working off of a transcript, you either don't find those signals at all or you find them too slowly because people also they snowball, right? And so if you start having a bad experience and the other party on the other end of the line isn't responding to that and trying to de-escalate, then you just feel like your concern's not being addressed and you keep snowballing it and making it worse. So not only do you have to detect it in the first place, but your system has to do it fast and respond quickly and accurately.
No, I got some like deep fake data from last year. Right now, I kind of don't have any deep fake data in 2026 to talk about, but I find that last year's data was really interesting. So the deep fake phishing attacks surged 1,600% from last year to from 2025 to 2024. Contact center fraud exposure is projected to hit like $44 billion in the US alone. A voice clone right now takes like 3 seconds to make, which is very impressive and scary. And really cool fact, 1 in 127 calls to contact centers is now fraudulent. Yet, like nearly half of the orgs out there aren't confident in their detection capabilities. So, what's actually happening right now on the front lines of voice fraud?
Well, the really tough thing about fraud and deepfakes and social engineering, which can cause fraudulent returns or cause security breaches if you give the wrong person a password reset, etc. These are really bad outcomes. The problem with these things is that a lot of times you can implement a defense, procedures, technology, etc., that works reliably to counter these attacks, and that will work and work and work and work. And then one combination that hits an agent who's tired, or you just change your policies, or any combination of these things, and then it doesn't work once. And that can be anywhere from thousands of dollars of return fraud to a $10 million data breach. So it's a very, very difficult problem because you can keep countering this stuff as it gets more and more prevalent, but it's not just is your defense better than their attack? It's also a numbers game. Even if your defense works 99% of the time, that 1% can still be extremely damaging.
What was kind of interesting was that there was like a finance worker at this large firm in Hong Kong that was like tricked into transferring, I think it was like $25 million to the fraudsters in 2024. That was like a really big thing. So can you walk through like just what broke down in that?
As with any big failure, multiple things break down, right? Like, one, obviously the technology fooled that person. Two, typically speaking, it's not just they sounded convincing with a deep fake, but they also conducted social engineering at the same time to create a sense of urgency, right? Like it's not every day that somebody calls you up and says, wire me $25 million right now. And you're just like, yeah, sure. Normal day of business. Fine. Just, wire the money. Done. Thanks. Talk to you again tomorrow. Right. These situations are combinations of attacks that are tried again and again and again until they work. And so it wasn't just, I call in and I use a fake voice, but I call in, I use a fake voice, I follow a script for attacking this particular person that's tailored to create a sense of urgency, create a sense of responsibility that if this person doesn't do what I'm asking, they're going to be in serious trouble. And again, many times that won't work, that won't work, that won't work until it does, and then you hear a news story about it.
Now, human detection accuracy for high quality deepfake audios dropped down to like 24%, which is basically barely better than like a coin flip. And it looks like 44% of orgs say that their fraud detection or prevention measures are creating their own problems. So the verification friction is so bad, it's showing up as like lost trust and customer churn. So how do you solve both sides at once where you're stopping the fraud, but then you're not, without stopping the customer?
That's a great question. Ultimately, you need to have multiple different, well thought out policies and technologies in place that combine together. So, one of the really important capabilities that a lot of folks overlook is passive monitoring and detection. So, you can have active procedures of I'm going to require multiple approvers before we wire this amount of money, or I'm going to require this authentication step before I do this password reset or add this multi-factor device. And those are very effective and very capable. But as we've talked about, there are going to be that 1% or 0.1% of the time where those individual active policies fail. If you couple that with passive detection, for example, listening with a synthetic voice detector to see is anybody calling in with a deep fake at all, you can find times and techniques that you're being targeted with before they hit that 1% or 0.1% where it actually works. Same thing with social engineering detection. You can run passive monitoring on every single call to see, is somebody trying to create a sense of urgency or create a scenario where an agent could be manipulated into doing the wrong thing? And again, that won't always work the first try, but eventually it will. If you detect that that's happening, that pattern of attacks is happening before it works, you can take measures to counteract that particular strategy, or even just warning people that something's going on, because a lot of these things are most effective when folks are unprepared and unaware, and they're tired, and they're not expecting an attack, of course. And so if you say, hey, we know that something's happening right now. We know somebody's trying to phish or trying to use deepfakes to impersonate. Be on your guard. That raises success chances by a ton because people are actually prepared for it. But you only get that if you're passively monitoring in addition to actively defending yourself.
And so the FBI issued a warning last year about AI voice clones impersonating senior US government officials. Enterprises are reporting an average loss of like $680,000 per voice fraud attack. And Deloitte projects the AI-enabled fraud's going to hit $40 billion globally next year. So the attack surface for voice has expanded so fast that traditional perimeter-based defenses are becoming irrelevant. So the question is like, what does a modern voice security stack today actually need to look like?
The good news is that these threats can be defended against. We know how to do it. But the problem with the expansion of this attacking capability and AI accelerating the rate at which adversaries can perpetrate these attacks is you can no longer hide through obscurity and say, I'm not a big enough target. Nobody's going to come and attack me. That has unfortunately been a relatively common strategy. Or you have a certain set of protections in place that are inadequate, and because you never hit a breach or never hit a fraud incident, you just leave it unaddressed. And the problem is that that is no longer just going to sit there and be unaddressed. Any vulnerability is going to be exploited because of this change in scale. The good news is that there are very common and very effective best practices to counter these if you take the time to do them. One of the most important things is to not just wait until there's an actual breach or actual fraud incident, but be proactively monitoring and taking action when you start to see threats or vulnerabilities. There's two pieces to this. Part one is red teaming. Do you actually try to perpetrate fraud, or do you actually try to create a security risk or security incident and see if your defenses are working? If you're not, the attackers are, and you're just hoping that it didn't work. But if you are proactively testing your systems and seeing how effective they are, you can catch those vulnerabilities and gaps before the attackers do. And if you combo that with passive monitoring, as we were talking about earlier, you can see changes in behavior that can indicate somebody's trying to exploit or trying to find a weakness before they actually find it. Coupling those two things together puts you way ahead of a lot of enterprises that are out there just waiting to be exploited.
I find it interesting that like 87% of consumers say they want companies to disclose when AI is being used in an interaction. 90% say that they should always have the option to reach a human. And yet, most voice AI deployments are making that disclosure decision based on conversation optimization, which is not trust. So, at what point does like hiding the AI become like a liability, like they're like a legal problem, reputationally, or like I guess like what do you think?
It's already a reputation problem. That point in time is already here. And in most cases, a lot of people want that disclosure and that ability to reach a human because they don't trust that the AI can solve their problem. I think a lot of folks aren't calling in and saying, oh, it's an AI. I just hate AIs in general, so I'm just going to be mad about that. They're calling in because they want to solve a problem. And when you reach an AI, you're thinking, this is going to take forever and not going to solve my problem. And I need to talk to a human anyway to get this resolved. So can we just hurry it up? This is wasting my time. That's the problem statement. That's why people want the disclosure. That's why people want the option to get to a human. And so the fix is one, to make the AI systems more capable, but two, weirdly, paradoxically, to make them optional. You should call in and we should start changing people's perception from, oh, I have to talk to this AI agent to get to a human, to the AI agent is a viable route to solving my problem. I have the human route too, but in some cases, I want to pick the AI agent. In some cases, it can be as simple as, for example, you call in and say, and get, there's an AI agent ready to assist you right now who can start helping to solve your problem. Or we will put you in a priority queue to talk to a human agent. You are welcome to choose, and you can change your mind at any time. Even just that presentation, giving the user the power to make that choice, many people actually choose, let me see if the AI agent can help me. And if not, I'll go back to the human queue.
Um, Gartner forecasts conversational AI will cut contact center labor costs by like $80 billion this year. That's at least the promise. And I find that like there's another metric. There's like Qualtrics found AI powered customer service fails at nearly 4 times the rate of other AI applications, which is super interesting. But nearly like 1 in 2 consumers who actually use AI for customer service saw zero benefits. So like what's causing this gap between like this $80 billion ceiling and then the reality where most enterprises are actually living in?
Well, the problem is ultimately that voice-based AIs have a lot of gaps that haven't been solved yet. We were talking about some of them earlier with the latency and perception. And again, a phone call with a human being who's frustrated and wants to solve a problem is a very emotional and empathetic kind of interaction. And while text-based interactions with LLMs have seen this big phase change, this big jump in capability post ChatGPT and post large language models, the voice-based UX is so key to any interaction between humans and technology that even if the models are smarter in some sense, if you don't solve the UX, people are still frustrated. And so you don't get a win. And of course, folks are taking these new AI capabilities and trying to apply it to every single consumer interaction. And the problem with that is the capabilities are only able to solve a small subset of, I would say, more easy or more routine problems today. And if you're shoving a technology in people's faces that isn't capable of meeting their needs, but you're deploying it out everywhere just because either it's more cost effective or because it has the promise to do better, then of course people are going to react negatively. And in the call center business, if people are reacting negatively, you've already lost the battle, even if in theory the technology could help.
And then one last question. 71% of Gen Z customers still pick up the phone when issues get complex or there's like high stakes on the line. Even like the digital native generation defaults to voice when it matters the most. So we do know that like isn't dying and it's becoming the trusted channel. So what does like the contact center look like right now in like 3 years?
Absolutely. The key point is that voice is still the highest bandwidth and quickest way to solve many complicated problems. Anything simple, as you pointed out, the digital native generation, they can go into the app and the website and do those simple operations. But when that fails, voice is the way that you communicate your problem effectively and quickly, confirm that there's a resolution and understanding, and also iterate quickly. Voice is a conversation, not just a monologue or an email. So I say, here's my problem. They respond, and I say, no, that's not quite it. What I really mean is this. And you can very quickly get to a shared understanding with the person you're talking to. And once you're at that shared understanding, they can help. So, in fact, voice is that trusted platform. And the contact centers that really get this right over the next 2 to 3 years are going to be very careful and deliberate about bringing in the most capable voice AI technologies that not only have the smarts and tools to solve those problems, but can understand the other user and build that shared understanding quickly and effectively. Even as simple as things like confirming that you're understanding what the other person is saying, that humans do naturally in a conversation. Can your voice bots make sure they have a holistic understanding of the conversation, including the user's emotional state and how that conversation's evolved, in order to respond effectively and build that trust with the user, with the caller, that you understand what they're asking about and can effectively solve their problem?
Thanks, Carter, for being on the show. And to the listeners at home, stay curious.